Hi everyone, Miss Nardini here. Today we're going to do a little bit more factoring and solving polynomial equations. So my first example here, the directions are to factor completely. So we want to be able to factor this as much as we can. So if you need to pause and write down the title and all that, go ahead. Now's the time. Example 1, x squared plus 8x plus 12. Now this is review. Remember that we have a 1x squared. When I make my two sets of parentheses, I'm going to have 1x and 1x. And then I need my last terms to multiply to 12. But I also need them to add up to this positive 8 here. So the factors of 12, 1, 12, 4, 3, 6, and 2. 6 and 2, and if they're both positive, will add up to 8x. 6x plus 2x equals positive 8. So just a little reminder on factoring. Our answer is just x plus 6 times x plus 2. So I do want to do some more examples that are a little challenging, but we are going to follow the same idea. So x to the 4th plus 8x squared plus 12. Now if you notice the difference here, I have an x to the 4th instead of an x squared. I still have an 8 and a 12, but I have an 8x squared and just 12. So again, I'm going to make up my two sets of parentheses. And to factor this, we have to know and remember that our first terms multiply to our first term. So instead of just x and x, I need them to multiply to equal x to the 4th. So the only way to split that evenly is x squared and x squared. And then I have 8x squared. So I still am looking to break up this last term 12, but to add up to 8x squared. Well, in this case, we're going to use the same 6 and 2, because now instead of just 6x and 2x that we had over here, we have 6x squared and 2x squared. So we still need them both to be positive. So now my middle term adds up to 8x squared. So when you see a 4 here, the process is the same. We just have to change how we split up our x to the 4th. Now we should always check our answers. So I'm going to go ahead and erase this here. And if we FOIL out this, these factors, we get x to the 4th plus 6x squared plus 2x squared plus 12. And if you combine like terms, we should always get back to that original problem. So we should always make it a habit to check our answers. Here's the next example. Example 3, 4x to the 6th minus 20x to the 4th plus 24x squared. Now remember, anytime we're doing any type of factoring problem, we need to look for the greatest common factor. So I start with the numbers. I have 4, 20, and 24. I can divide all of those by 4. And now I need to divide by as many x's as possible. So I have x to the 6th, x to the 4th, and x squared. So that means that the maximum I can take out from each is 4x squared. So then I just need to write down what's left. 4 divided by 4 is 1. X to the 6th divided by x squared is just x to the 4th. I got minus 5x squared plus 6. Once I have that, I need to just remember that the problem said factor completely. So when you factor completely, that means it's awesome and great that we took out the GCF, but we still have to factor the rest of the problem. So I leave my GCF in front, and I make my two sets of parentheses. Again, I have an x to the 4th, so when I split that, I have x squared and x squared. And now I need to split up 6 so that the two numbers multiply to positive 6, but add up to negative 5. So the only way to do that is if I use 3 and 2 and make them both negative, because then I have negative 3x squared and negative 2x squared, which adds up to negative 5x squared. Lastly, a negative times a negative is a positive. So that all works out. And we would FOIL it and distribute to check our answers. Alright, so there's one more example that I would like to do before we move on to solving. So we're going to factor one more. Example 4 is 81 x to the 4th minus 16. And remember, we did difference of squares in chapter 5. If I have a difference, meaning subtraction, between two perfect squares, it's pretty nice and easy to factor. Remember, the square root of 81 is 9. We got x squared. We've got plus 4, because the square root of 16 is 4. And then I have 9x squared minus 4. So we have to be careful because it says to factor completely. So I need to look at my binomials to see if I can factor them anymore. Well, since there's a plus sign here, it's not the difference of squares. So that can't be factored anymore. But here is subtraction. So that is a difference of squares. So really, I can factor this just a little more. I leave my 9x squared plus 4 binomial, but then I need to factor 9x squared minus 4. So this is a difference of squares. So I have 3x and 3x, and then I have plus 2 and minus 2. So you do need to make sure that you're factoring everything completely. So you're answering the problem correctly. Remember, we're factoring completely. I highlighted that for you up here. All right, so that is factoring. Now let's move on to solving for real and imaginary solutions. If you're given the problem, let me write this down. Example 5. 2y to the 5th minus 18y equals 0. I'm going to solve this the best I can. So if I can solve by factoring, I'm going to do that. I notice that I can take a 2 and a y as the GCF out of this problem. So I'm left with y to the 4th minus 9 equals 0. Remember, we're always trying to factor completely. So I have 2y, and this is a difference of squares. Y squared plus 3 and y squared minus 3. And this all equals 0. And now if we remember back to chapter 5, we did solve by factoring. What that means is each term could equal 0. It's because the product is 0. So any one of these could equal 0, so we have to set them equal to 0. So that means, let me get my pen here, 2y equals 0, y squared plus 3 equals 0, or y squared minus 3 equals 0. Then all you need to do is solve for your variable. In this first one, if I divide both sides by 2, y equals 0. And that's one solution. If I subtract 3 from both sides here, y squared equals negative 3. Take the square root of both sides. Remember that the square root of negative 1 is I, and the square root of 3 is left over. And now, none of us are going to make this mistake ever again. We're going to remember to do plus or minus anytime you take the square root of a number. Anytime. So we, excuse me. So here we have two solutions, right? We have positive I root 3 and negative I root 3. Then lastly, we have y squared equals 3. And then I can take the square root of both sides. And you're going to remember what I just said. Our answer is plus or minus the square root of 3. So these are my 5 solutions. Positive square root of 3, negative square root of 3, plus or minus I root 3, and 0. So these are all the y values that we could plug into this original equation to be 0. And then it's good to recognize which ones are real and which ones are imaginary. And remember, I is an imaginary number. So these two are your imaginary roots. 0 is real, and the square root of 3 is real. So this equation has 2 imaginary solutions and 3 real solutions. And that's all I have for you tonight. So come to class prepared. We'll do some more examples and get to practicing. See you then.